hopefully everybody's seen what I'm seeing. I apologize. I made a few updates, especially to the second part 2 of the data access tutorial last night to fix an issue or two. So if you haven't had a chance yet, go ahead and fetch those changes to your clone of the repository in Jupyter Hub so you can see those. And it's more important for the second part. Not as much, there's new stuff in this intro, but more important for the Earthdata library tutorial. So
would you mind zooming in a tiny bit to make your text bigger?
Oh yes, thanks.
Thank you very much.
Is that good, or go one more?
I think one more.
Okay. Sorry, I have it on a giant monitor, and I know that some people are on.
That's great, thank you.
So better?
Yeah, good.
All right. Let's see, I gotta move things around here just a little bit. I'll move this over here. So just a good morning to everyone. My name is Mikala Beig, and I work at the National Snow and Ice Data Center as a data support specialist in the user services group there. And one of my main jobs is making sure that you can find and access the data that you need. ICESat-2 data, but also all of, and ICESat-2 is one of the product teams that I help support, but other people in my same role, we support all the product teams at the NSIDC. And so we can answer questions. I can help answer any questions about data access this week, but I also want you all to know that you can reach out to us at any time at nsidc@nsidc.org. And if you need assistance finding the right data set or accessing the data or downloading the data, and I just want you to know that real people read and respond to these emails every day that we get for any of the data sets that are archived at NSIDC. And if we can't answer your question, we can definitely get in touch with someone who can. So please do reach out. Before I move on, I want to give a huge thank you to the Hackweek organizers who put together this great event. I'm totally amazed and impressed by all the work that goes into making this week possible, from managing the technology aspects to helping develop content and organizing all the people. It's been an honor and a lot of fun to be a small part of it. I want to thank Jessica Scheich, who is delivering the second half of this tutorial and who has been a great resource to me throughout preparation. And I also want to thank the people at NSIDC who have helped create these notebooks and develop these tools. We have a whole team at NSIDC who thinks about how to make data more accessible to users and how we can help develop tutorials, how we can get all of you past the data access part and working on your science, which is the fun part. A caveat for this tutorial: there is way more in this notebook than we can cover during this time slot. And this is meant, oops, sorry for my notifications. So this notebook is meant to be used as a resource to come back to later. We're not going to go through every single bit today, but do take some time later to go over things in more detail. And don't worry about absorbing every bit right now during this time. I'm really excited to let you know that all of you ICESat-2 2022 Hackweek participants have been given temporary early access to select cloud-hosted ICESat-2 datasets by the NSIDC management team. The cloud-hosted datasets that will be available to you this week are ATL 03, 06, 07, 08, and 10. And these data are not yet publicly available, and so their use comes with some caveats. So I'll mention the terms or conditions of use now, but these terms of use will you'll also be able to find them in a PDF in the Jupyter book, and we'll make sure to point to where those are. So just briefly, some conditions of use here you can see. The NSIDC DAC Earthdata Cloud System, and Earthdata Cloud is where our cloud location, where cloud data are being migrated to in the cloud. It is still in development and it is not fully operational. So this means that the system should not be used for operational purposes. It does not have the same capabilities as the current operational on-premises stack system. And while the system has been quite stable and reliable, it is subject to changes, delays, downtime, and inconsistencies in behavior. So just a warning. NSIDC DAC is actively ingesting data into the Earthdata Cloud system. And so what the data that are available may not represent the latest version, although what you guys have access to this week are the latest version of those data sets. But you also need to keep in mind the entire time series of the data might not all be in the cloud yet. Although, again, I think for the 5 data sets that you all have access to, it might just be ATL03, which is so huge that it might not have the full time series yet. I think the others are mostly there. And then just to say, support for accessing and working with the early access NSIDC data, support is limited. So especially after this hack week, response time might be slower than normal. And we don't really have dedicated operational support staff supporting early access users yet. And then just so you know, this access is time limited. So early access for folks here will end on April 30th. So, all right, getting past all that here. So we might need to run this cell. Let's see. Uh-oh, are you guys able to run that one? Here, I'm going to open it in here if we can't. So hopefully it's rendering for you. It's not for me, but we can look at this. Let me make it a little bit bigger. So that first cell in the notebook, I'm not sure what's going on. Hopefully I have the right copy open of my notebook.
Mikala, I think you need to restart your kernel.
Oh, thanks.
It says no kernel at the bottom.
Oh, nice. Thank you. Well, let's start that first. Oh my gosh, I hope I didn't time out on with my Jupyter Hub open during that time.
It looks good.
Okay.
You have a kernel at the bottom now.
Phew, thanks. Thanks for, there we go. Okay, awesome. Okay, so we put together this table. This is by no means an exhausted list of all the ways you can access ICESat-2 data. But we thought this might be helpful to sort through some of the different ways. So a table that features some of the different strengths and capabilities of some of the different methods that we're going to talk about this week. I'm going to super briefly touch on some of these graphical user interface or web-based methods, and then I'm going to dive into this Earthdata library for the second part of my tutorial, which is a programmatic method for discovering and accessing ICESat-2 data. There are so many ways to access NASA data. It can be really confusing at first. So don't feel like you have to, like I said, absorb this whole table right now, but come back and browse through it later. So there are a lot of people all the time thinking of ways to make NASA data more available. And so it can be really confusing at first. It can be really confusing even later when you're more familiar with the Earthdata system. Today's tutorials will give you a jumping off point to start your data exploration on your own. And ultimately, you'll just have to play around and figure out which methods will best support your workflow. Don't hesitate to reach out to me or Jessica or anyone in the help channel if you are trying to figure out what method might be well suited to your particular science workflow. All right, here we go. So as I mentioned, ICESat-2 data are archived at the National Snow and Ice Data Center. Currently, all data are still available from our on-premises servers, but NASA and the NSIDC are in the process of migrating data to the Amazon Web Services Simple Storage Service, or S3. Some of the methods that we'll talk about today will allow you to access data both on-prem and in the cloud, and some are still just for on-prem data. And like I said, I won't have time to go through every line of this notebook, but please do come back to it. I wanted you to have more information that we can present today as a resource for later. Let's see. Go on. There's just some extra information in here about ICESat-2 data resources at NSIDC. Ben gave a really nice overview of the data set landing pages. You're gonna need to render that one again. This is one place you can access ICESat-2 data through a web-based interactive map. Note that through this method, you don't have customization or subsetting either spatially or temporally. With this method, you'll get whole granules. But and I want to mention that even when downloading data from our site, you will still need an Earthdata login. All of NASA's data are behind that Earthdata login, no matter your access method. Okay. So dataset landing pages, it's one resource for you to access and download data. The next thing I want to touch on and make sure that I show all of you is finding data in Earthdata Search, and in particular cloud hosted data, since for NSIDC anyways, that's kind of a newer feature. So let me find not that one. So if you guys can go over to Earthdata Search, you have a link there in your notebook. So this search earthdata.nasa.gov search, head over there. That's where I am. And in the text box in the top left, go ahead and type in NSIDC_CPRD and hit return. This is going to list collections that the NSIDC DAC has made available in Earthdata Cloud. And then you can additionally filter for any other temporal or spatial or keyword constraints that you normally would when you're using Earthdata Search. So I'm going to go ahead. Oh, I kind of already did. Let me go back a little bit. So this is where you would be looking for NSIDC_CPRD. You should see 5 data sets, the 5 that I mentioned earlier, available here. And I'm filtering on provider ID here, and the CPRD gets you to just the cloud hosted data. So I'm going to click on ATL06. And one thing I want to mention too is, so we're going to be talking a lot about the common metadata repository throughout the week. That's how you interact with the catalog of NASA data. That's the common metadata repository, is a catalog of all the data sets, metadata for the data sets that are housed at NSIDC and across the DAC system. Something that I find handy to do is, if you can see these 3 dots to the right of the collection name, if you click on those and select collection details, you can get into a view of some of the metadata that's available in the CMR. And you can do that that was collection or data set level metadata. And then you can also, whoops, wrong collection. Let's go back. You can also do that at the granule level or file level with these 3 little dots here and selecting view details. So this is nice when we're looking at the Earthdata Library programmatic access method later. I'll be talking about CMR and metadata fields, and this is another way that you can look at those metadata, and it can be a nice way to browse through things when you're first starting to get familiar. So you can download a single science granule by clicking this button here, which is the looks like an arrow pointing to a disk. You can select multiple granules by clicking on these plus on the plus signs. Or let's remove all of those. Or you can download the whole data set if you want. Please don't do that today, especially by clicking on the download all. But let's just grab a couple. Click on, now we've narrowed the number of granules. Click on the download button. And we're going to go ahead and place that order. So hopefully this has been really fast. Click on the download button over here in the bottom left. It's been really fast, so hopefully that continues to be the case. And so what I really wanted to show you here was the links that you get when you do that. So this looks very similar to when you use the same method to download on-prem data, but I just wanted to point out to you. So under the download files tab, you'll get a list of single or multiple HTTPS links. These, and you can see that they have Earthdata Cloud here in the URL. These allow you to download data from the cloud like you normally would do from our on-prem server. And by using these HTTPS links, these allow you to download data without incurring egress costs from AWS. So that's a nice feature to allow you, if you want to continue using your normal workflow on your own local machine rather than working in the cloud, you'll always be able to continue to do that. But you'll want to make sure to use these links. So if you click on the second tab, the AWS S3 access, you're going to see the S3 data object URLs. And this is where the data are in AWS S3. And so these are the links you would use if you were going to access the data directly from an EC2 instance. For instance, you can do that this week because our Jupyter Hub is also is in AWS US West 2 region, which is where the NASA data are located. Let's see. Then, okay, let me hop back over. So hop back over to your notebook. Again, just some more background information. So we're going to move on to the programmatic section of the tutorial next. I want to also draw, sorry to scroll around and make you dizzy, but I also want to draw your attention to this section of the tutorial, exploring data using open altimetry. Open altimetry is a great web-based tool for visualizing the data, selecting data, figuring out where the data actually land on the Earth. You can see, it was like those nerd ropes from Ben's tutorial. You can see where the actual data points lie on the Earth's surface. You can download subset data from open altimetry. So I really encourage you, I have a couple of tutorials linked here about open altimetry. So if you're not familiar with that tool yet, go ahead and navigate to those later in your own time, and you can get a little bit more familiar. So I wanted to do a polling question. So if you guys want to, I think Jessica is going to make a thread in the tutorial prompts channel in Slack. And if you guys could think about how do you prefer to search for data, for ICESat-2 data, maybe in particular, prior to downloading files? Do you like to do this like with Earthdata Search or Open Altimetry, dataset web pages like you've seen for the web-based methods? Do you like to just dig right into CMR? So just hop over to the Slack channel and just take a minute or two to answer that question. I'm gonna pop over to my other notebook. Make sure I have a kernel.
While we're doing that, if you wouldn't mind, again, increasing your font, it's a little small, at least on my screen.
Yeah, you bet.
Thank you.
How's that?
That's better.
Here, I can also, I don't know if that's any better.
That does help a bit, yeah.
Let me, what about that if I?
Yep, that's great.
Okay, great.
While other folks are answering the question, I just put this in the chat, but I'd like to recommend that folks, if you are having access issues, particularly with the cloud data, that you try to focus your energy at the moment on the really great stuff that Mikala is presenting, and we can help you guys troubleshoot on a case-by-case basis after our tutorial later today.
Yeah.
She's presenting some really cool stuff, and so it's easier to take care of permissions issues later.
Oh yeah, yeah. Please do reach out if so I meant to mention that. Thanks, Jessica, too. I meant to mention that in order to have access to the cloud data early access list, you need to have given us your Earthdata login username, as well as the email you use to set up your Earthdata login. We can, if you weren't able to do that, I can probably still get you on the list. So just Slack me your, again, username, and then the email you used to set up your Earthdata login. It's important that those match. And we can probably still get you set up. No guarantee, but it's pretty likely. All right, so I'm gonna look at the Slack prompts, let's see, later. I'm not ready to like adapt my tutorial on the fly for those responses, but I'm really curious to look through those later and see what tools you guys are using already and what your preferences are. So I'm going to move over to this. I'm going to present an introduction to a new work in progress Python client library that Luis Lopez here at the NSIDC has been developing. This is a programmatic access method, so switching from the web-based methods. This Earthdata library allows you to search for and preview files, and then either download or get direct access to NASA data sets across the DACs, and not just ICESat-2, but all of the NASA data sets. And you can access data that are hosted both on premises and in the cloud with this tool, which is really neat. I want to mention again, it can be really confusing to know which tool to start with when you're learning, especially how to access data programmatically. There are even more choices for programmatic access than for web-based. Here, this list just shows a few other Python client libraries that are out there for interacting with CMR and with the NASA DAC APIs to discover and download data. Each one has its own strengths and capabilities and are great. The motivation behind Earthdata was to create a client library that was particularly user-friendly so that you can spend less time finding and accessing the data you're interested in and more time on your analysis. So in that spirit, some of Earthdata's key strengths are that we can use it for, as I mentioned, accessing data both on premises or cloud hosted. And That's a really nice feature. You can search for data across all the NASA DACs, multiple data sets. And one thing that I really appreciate is that it handles credentials nicely for us, especially the S3 credentials when we're accessing cloud-hosted data. So it kind of handles that behind the scenes for us, so we don't have to worry about the particular cloud provider S3 credential user endpoint to go to create the access keys and token that we need to access data that are in S3. I'm a super new user to this library, and I'm a new user to programmatic access through CMR and DAC APIs in general. And so I especially appreciate sort of that behind the scenes handling of credentials. Another caveat, since I'm a new user to Earthdata, I might not be able to answer all of your questions, but we have other folks here from NSIDC who can. And so just please put questions in Slack if you have them in the help channel. If we can't answer it right away, we'll get to it as quickly as we can, but we try not to leave you hanging. And then one last caveat. There is a lot more capability within the Earthdata client library than I can show you here in this time slot. So this tutorial is by design, really simple and pared down, but I encourage you to go to the NSIDC Earthdata GitHub repository where the Earthdata library lives and dig into the demo notebook there. I've included links to that in this notebook, and start playing around in there when you're ready to do that and explore more deeply Earthdata's capabilities. And just want to mention that this Earthdata is in development still. It's being improved often, and you are encouraged to contribute. So let's see. So some of the main things that are in common for all the different programmatic data access methods are that you have to go through some key steps. You have to authenticate with your NASA Earthdata login. We need to query CMR, the Common Metadata Repository, so that we can find the collection we're interested in. And then once we've found the collection we're interested in, we can find the specific granules or files that we're interested in. And then we can order and download or get direct access to our data by interacting with the DAC API. So we're going to go through two pretty simple examples of this. I'm going to go through one workflow for downloading data from on-premises, and then we'll pretty much repeat that same workflow exactly, but accessing the same data, but in the cloud. And fingers crossed that this all goes well. So before we start, if you're following along, go ahead and we'll need to import those classes from Earthdata. Earthdata is already nicely set up in the Hackweek environment, so that's great. So that was step 0. First thing we need to do then after that is log on to Earthdata. So this should allow you, if you've already set up an NRC file, this should find that and log you on that way. And if you don't have that set up yet, should give you the option to enter your credentials interactively. So, all right. So authentication, step 1. Next thing we need to do is start querying CMR. So the data collections class has methods for filtering for and narrowing down your search using different CMR metadata fields like keyword. You can sort or filter by temporal range, area of interest, the data provider, Data provider can be a trickier one. You can use the provider ID for the different DACs, and I've included a table. Sorry for scrolling and making you dizzy, but down at the bottom of this, there's just a little cheat sheet to help you know which data provider ID corresponds with the different DACs. Okay, so the first thing we are going to do is set up a query object by calling this data collections class and filtering on keyword land ice. I have a particular data set in mind that I want to use for this tutorial. The files are nicely sized. So we don't want to be trying to download ATL03 during this. We're going to use this bounding box or spatial extent. This is an area over a mountain range in Alaska, kind of on the border between Alaska and Canada to the southeast of Juneau. And I'm going to look specifically for data in our on-prem location. So NSIDC _ ECS will be querying on-prem collections. I just want to point out here, you can also filter on DAC. In this case, we would use .DAC in NSIDC. Data centers also a possibility. For this query, we're going to go ahead and use provider ID. So run this cell. It's going to let us know with this .hits method, it's going to let us know how many collections were returned in that search. We can see that we found 144 collections or data sets that satisfy these search parameters. We don't want to look at all of those for sure. The collections objects are really quite large, as you'll see in a minute. So we don't want to grab 144 of them. That's why in this cell, we're going to limit it to just getting 10 of those, just so we can start playing around. We're going to create a collections object from our query, and we're just going to look at the full first result in that list. So go ahead and run that cell. And you can see that you get a lot of output from CMR. So this is a lot more than probably we'll usually want to try to sift through. You can see there are data access links down here, the DOIs. So just keep going down. All kinds of good information in there, but we don't need to look at all of that every time. Maybe once is good. So what we're going to do is use we're going to use this fields method to narrow down the data that we print out about this collection. So if you run this cell using this fields, we're going to grab just the short name and the abstract from 5 of those collections in our list. So running that cell, you can see we're getting a subset of metadata now, which is much easier to read. You can see the short name ATL06. This is the collection I'm going to use for this example. You can get a little synopsis about the data set. This concept ID we're going to see later is really important. So just take a look at that. One thing to note is that, the results from data collections are enhanced Python dictionary objects, which means we can parse out which metadata fields that we want to display like we did above. Here are some other ways to grab just the information you're interested in. And then if you look at, so let's just go ahead and run these 3. Got to run this way. You have to run them one at a time for them to display each one. This is delved into much more deeply in the demo notebook that I mentioned above, but I just wanted to start showing you some of the capabilities. So the next thing, now we know what data set we want to grab files from. And so I'm interested in the ATL06 version 5 data set. And so when we're filtering granules now, we're going to be focusing on ATL06. Like I mentioned before, concept ID is important. The concept ID for a collection is a unique identifier. And so if you know exactly which data set you want to query, using concept ID will make sure that you don't accidentally get older versions in your query or both cloud hosted or on-prem versions in your query if you hadn't pre-selected for on-prem. So it's really good practice that once you've identified your collection of interest, to go ahead and build your subsequent queries on the concept ID. So we're going to do another filtering. Data Granules has similar methods that work for narrowing down your search, like Data Collections does. And so we're going to create a query object. This is the ATL06 concept ID. We're going to use that same spatial extent over the mountain range in Alaska. I'm going to limit my search even further with this temporal constraint and only grab data during March of 2020, just because I really want to narrow down the number of hits that I get. Running that cell, found 4 granules that satisfy those constraints. So we're going to go ahead and create a granules object by grabbing those results. And we get some more metadata here about each of the granules. You can see where they're located on the NSIDC, file name, and some details about each of the files. Another nice feature, since we're in a notebook, we can take advantage of this display function, and we can look at some preview images of the granules. Here I just grabbed 2 of them. So we can take a look at what are called, we refer to them as browse images. They're previews or little thumbnails of data, so you can see what you're looking at before you start downloading data. Make sure it's where you meant and what you wanted it to be. So if you look, it's hard to see, this is pretty small, but you can see the data are located here in Southeast Alaska, and then a preview of some of the variables within those files. So that's steps 1 and 2. We queried queried for our collections, narrowed our search down to some specific files, and now we're actually ready to just grab and download some data. We can run this cell. We're using the store class in Earthdata, and we're going to put these files, like Ben mentioned in his tutorial, in this temp location in the Jupyter Hub, and help. Like he mentioned, the reason there is to help. Oh, I just got a note from Luis saying, remember, we ran into an issue before where this needed a slash at the end of the path. So we'll stick that in there. I think it actually went okay when I tested it earlier today, but go ahead and put that in there, and we're going to run this cell. I already downloaded this earlier during a test, so to actually make this a little more like what you would be seeing, let's grab a different granule and run that again. You can see what it will look like when you're downloading it yourself. And then if you want to see, if you want to earlier I was having trouble figuring out where is temp and where did those actually go. So if you hop over to a terminal and put in, let's see, where are we? That command here, just list /temp, hopefully it should show us where that, what's inside there. And you can see that we created that demo ATL06 directory. And there are files, the granules or files that we just downloaded will be inside there. All right, I think I'm going over time, so we're gonna keep moving here. The second example in here, we're gonna do essentially the same thing, but we're gonna access the data, the cloud hosted version instead of the on-prem version. So we already generated our, we logged in with Earthdata login, and that's going to handle our S3 credentials for us when we get to the step where we're going to actually directly access the data. But the first thing we're going to do is run that same query, but this time I'm going to specify that we want to look at this NSIDC_CPRD data provider, because we know that's where NSIDC cloud hosted data are. In this case, for running the, for accessing the data in the cloud, because the ICESat-2 data are not publicly available, you'll need to pass this auth instance into data collections. Later, when all the data are publicly available, that won't be necessary, but up until then, we've got to do that. So if we run this cell, see how many collections satisfy that query, and we see with this method we don't see any. So not to worry, it's just because these data are not yet publicly available. So this particular method is not going to return anything. If these were, so other DACs have cloud hosted data that are already publicly available and not just to early access users. If you ran the same method on a query for those data sets, you would see a return there. But we have a workaround for that. If you create a collections object and grab those, we can print the length of that list, and that'll tell us how many collections satisfy. So we can see 5. This is essentially the 5 data sets that we have available to us this week. And we're going to just take a look at the metadata for those, but we filtered on just short name and abstract, so we wouldn't get all of it. So we can just read what we want to. So you can see those 5 data sets. And then like we did before with the granules, looking for just the granules we want in a certain location and point in time or time range. We're going to query for the same, not the same concept ID. This is now the concept ID for ATL06, but in the cloud. But we're going to use the same bounding box. We're going to narrow it, filter just on March, and see which, how many hits we get again. And again, there are 4 granules that satisfy those constraints. You can run this cloud hosted method on your list, and it'll let you know, are your data cloud hosted or not. We can see that's true. And now we can go ahead and access the data. We can do this portion because we're in an EC2 instance in US West. Good, that has the slash there. So go ahead and run this cell and cross our fingers, see what happens. so it was able to grab our S3 access keys and token that we needed by hitting that NSIDC S3 endpoint. So all that is handled for us. You can see that it accesses the S3 data objects where they're located in S3. And that is basically it. Here's a little recap. If you were reading through the beginning of the notebook, you can really query, find, and download data with as few as 4 lines of Python. So there's an example of that there. And then I just also want to remind everybody, this is pretty simple example, didn't show all of Earthdata's capabilities. So please use it on your own, start exploring more on your own, and you can grab it there from the Earthdata GitHub repo. And that is it. I'm going to pass it on to Jessica, who's going to talk to us about Icepix.
Thanks, Mikala. So I'm gonna start with posting another one of those fun prompts in the Slack channel. And then I'm just gonna go quiet for about 3 minutes just to give everybody a chance to answer that question, and also, stand up, run to the restroom, whatever it is you need to do to make sure that you're ready to go for the last bit of tutorial before lunch. So quickly, just to start off, we realized a small gap, and we overlooked actually walking through the process of updating your cloned copy of the repository on the hub this morning. So I'm going to quickly go through that to start with, so that those of you who maybe haven't been able to get those newest edits in can get more comfortable with practicing that process. So I need to share my screen. Let's move the Zoom controls. Okay. So for those of you who have not already cloned the copy of the website, there are instructions on how to do that on the Jupyter book. You can also go to the, let's see, if we go to our Hackweek repository, and we can copy the download link here. We can copy that link and then come here to our Git, and we can clone a repository, and you would enter that URL here and click clone. I already have a copy of the repository, so I'm going to instead go into that repository by double-clicking, and I am going to say pull from remote because I want to update what I have. We can see this fun little thing up. It failed to pull. I can see why. So I have not gone through the process of setting up the tracking information to let it know where it needs to pull from. Scott and Joe, would you like me to walk through that process now, or?
I think once you are cloning with the little widget there, it should do it for you. So maybe you just do it manually at some point.
I did clone it manually in the terminal.
Yeah, so they should be fine using the little widget.
Okay, cool. Then I will proceed. I recently updated my clone via the terminal, where I manually specified that information that it was looking for. So we just wanted to make sure that we went over that, and as always, if you're having issues with updating, definitely reach out to us in the Slack channel, and folks will work with you to get that straightened out. Moving back to the task at hand, I'm going to tell you guys talk a little bit more about another data access option, in particular Icepix. I I really enjoy and think that these are some of the same issues that I've experienced with accessing ICESat-2 or other data programmatically. There's a lot of discussion about large data sets and how we get portions of data sets, knowing what's available and where to find it. And thanks to Scott for the issue that I think many of us have been having very recently. I had it this morning actually, which is authentication. And hopefully some of the techniques you're learning this week will make that easy for you, and we're happy to help troubleshoot. We're actually going to spend a few minutes after lunch walking through setting up some of these authorization options to hopefully get everybody up to speed so that we stop getting access errors. Okay, so moving into Icepix. What is Icepix? And I think it's also really cool to hear the story of where Icepix came from. So Icepix was actually started partway through a Hackweek, at the 2019 ICESat-2 Hackweek. Several of us got together partway through the Hackweek and sort of formed a new project group to start thinking about ways that we as a community could come together to deal with some of the programmatic data access challenges that we were all facing. A lot of us were in different project groups, and we realized through our conversations that we were all having similar problems with data access and all solving them independently. And so the idea behind Icepix was, can we put all of that, great brain power and troubleshooting into one space so that the next people who try to get ICESat-2 data don't have to deal with those same challenges and can get to the part of doing the really fun, fascinating, cool science faster. At that time, the Earthdata library didn't exist. That being said, there have been a couple questions in Slack, and I'll remind you of this figure that Mikala showed, which is also in the Jupyter book as an ICESat-2, in the ICESat-2 resources guide. And what we've done here is there's a lot of different access tools for getting and working with ICESat-2 data, and they can be very difficult to navigate. And so we've tried to put this chart together to really give you guys a great sense of what tools excel at which things and why you might want to use the different tools. So Earthdata is a really powerful library for handling authentication, for handling getting a wide variety of data sets. But currently, since it's relatively new, and because it excels at that wide breadth of data set access, it doesn't do certain things that can help us a lot with ICESat-2 data sets, like thinking about getting more manageable sized data. That being said, we are working together on these. They're both open source tools, and we'd love to hear what your problems are and what your successes are, as well as think about ways that you might be able to contribute to the libraries. And with that, I'll highlight some of the things that Icepix has that go beyond data access. So there is an ability to read data into an X-array. So one of the things that Icepix has is a ICESat-2 variables aware module, if you will. So this is a variables module that knows that ICESat-2 has all of these really complicated nested data variable structures, and it tries to make it easy for you to say, I would like just these particular parameters, and communicate that, whether you're communicating with NSIDC to order data or whether you're trying to read that data in, so that you can try and subset on those variables without needing to manually hard code a long list of particular variable paths that you want. Another thing that Icepix has is cloud data access, and it's a virtually identical interface to how you would access the data if you were downloading it. So there's not a whole lot that you have to change, and I'll highlight this at the end. And then another thing that we're working on, which many of the organizers here, I'll shout out to Kelsey, Zach, and Ramina, they have been working since their project group formed at the 2020 ICESat-2 Hackweek. And they have recently put through and implemented the infrastructure for a module called Quest, which is the Query, Unify, Explore Spatiotemporal module. And what this module aims to do is it provides the infrastructure for adding new data sets to your analysis. So it lets you create a single object, which Romina will talk about a little bit later on today, and gives you a framework for saying, I'd like to bring in this data set. These are the pieces of information that I need to tell Python how to handle in order to get that data set. And then I can bring those all into one space. We're in the process currently of having the first example data set to go with that, which is Argo. And I know I've talked to a couple of you guys in project teams about the possibility of doing this for something like Sentinel. So with that, I'll start actually running through this tutorial. As with Mikala's tutorials, there is a lot of information here, a lot more than I'm going to be able to cover. And part of that is because I'm trying to make this a reference for you guys for when you go back later and are wondering what the various options are. Icepix does also have full documentation on Read the Docs. I'm sure I put a link in here somewhere, and if not, I will make sure that gets out. Which also provides a lot of information on the different functionalities that it has. So just to start, I'll go ahead and import the Icepix library. Similar to what Mikala did, but we'll approach things in a slightly different order for Icepix. There's a few key steps that we have for accessing data. The first one that we're going to take is defining what those search parameters that we have are. We're going to then query the data set. In particular, we're going to query that CMR library. This can be done with the exception of cloud data access without an Earthdata login. Then we're going to go ahead, log into Earthdata, and go ahead and actually think about ordering and downloading our data. So there are multiple different ways to search for data in Icepix, ICESat-2 data in Icepix. In all cases, you have to let Icepix know what data set you would like, which ATL OX you are interested in getting, and you have to give it a spatial extent. I think this probably makes a lot of sense. You can give it a spatial extent in a couple of different ways. You can provide polygon coordinates, you can provide a bounding box, or you can provide a polygon file. You can use a geopackage, a shapefile, or a KML file. And then for all of the products that aren't gridded, you have to provide some additional information so that it can narrow it down to a reasonable sized data set for you. This might be the date range, or you might want to use cycles and tracks. Here we're going to use a bounding box. So I've set these parameters up with the bounding box. We have our short name, we have our spatial extent, and we have our date range. So I'll just set those up. And then we can go ahead and create what's called a query object in Icepix. So this created our query object, and there are a whole bunch of different things that we can view about that object. So we can look at the product. Great, we have the correct product in there. We have the right dates that we requested. I didn't specify a start time or end time. These are things that you can set, but so it just starts at the beginning of the day and ends at the end of the day. I didn't ask for any particular cycles or tracks, so we don't have any information set there. And I did not specify a version, so we're going to get the most recent version from NSIDC of this data set, and the most recent version of ATL06 is 005. And then last but not least, we want to make sure that we're looking in the right spot for our data, so we can call this visualize spatial extent function, and it'll draw our region for us on a map. We can use that map if we want to scroll in and out if we need to get a better sense of where it is. And there also is some visualization options that will pull data from the Open Altimetry website and plot some interactive maps for you to actually get a fast view of the data elevations for the area that you've requested. And this can be really handy for particularly for coastal environments if you're looking to see if a particular product actually falls and has data in the area that you need it to. I mentioned these parameters before that you are able to request. So I won't go into them in any more detail. Now that we've searched CMR for this information, we might want to know a little bit more about the product that we're looking for. So a lot of this information is what Mikala was showing you when she was talking about how the information was stored as data dictionaries. And so what Icepix has done is taken this data dictionary and said, these are the things that most people will probably want to know about. So we'll make it so that we can print them for you really quickly right here. But if there's a piece of information that's missing, you can also see all of that entire dictionary in all of its great detail for every single one of the granules that you have found with your search. Okay, so now that we have gone ahead and queried our data product, this is just a way to see what information has been submitted to CMR in our query. When we want to know what granules or files are available that might have data in the area we're interested in. And again, this is just looking at some more information about those granules and files. As Ben talked about earlier. And again, a lot of really detailed information, so you can see anything that NSIDC has and CMR have available for you and parse that information as needed for your application. So now that we've done that initial step, actually, I'm going to skip slightly to this figure. So we've been doing a lot of talking about filtering and subsetting, and I found this figure immensely helpful for understanding what's actually happening behind the scenes. So this isn't, unfortunately, for ICESat-2, but the idea is the same. In that initial step, what we're doing is we're saying we have this area of interest, and we're filtering the data, we're calling CMR, and it's using the metadata for each individual file and saying, this is the list of files that might be available for you. And so that brings us to step 2. Our list of files, our list of granules, is all of these pieces of data that we see here in the colors. But in most cases, we asked for the data inside this box, right? We don't actually need to get all of this other information from the files. And so subsetting, which is something that depends on the particular product, what your subsetting options are. For ICESat-2, you can subset based on time, you can subset based on your spatial extent, you can subset based on variables, and there are a few other things, but those are the critical ones, and the ones that are, I think, for me personally, have been the ones I've used most often. And what those will do is that means that NSIDC, when you place an order for your data, all of that subsetting happens on the NSIDC end, and you only have to download the data you actually want to use. You don't get this big list of files, this big set of files, and then have to subset them on your own after the fact. NSIDC does this heavy lifting for you. So that's one of the really great advantages to using Icepix, is that it helps facilitate the subsetting process for you and makes it a little bit easier. So as we've been saying, in all of these cases, we need to log in to Earthdata. I do not know what this password is, so I'm going to put a fake one in and let it re-ask for my username so that I can enter my credentials. And now this cell has successfully completed, which means that I have now successfully authenticated with Earthdata, and I will be able to order and download data. So I talked a little bit about subsetting. In many cases, so as with other things, what Icepix allows you to do is have complete control over what subsetting you do or don't do, but it will automatically do that spatial and temporal and subsetting for you so that you don't have to think about implementing it and you're actually only getting data for the areas that you want. If you want to see more information about what's happening, you can do that through the subset parameter dictionary. And in our case, we can see that it'll be subsetting, as I said, on time and bounding box or geospatial. So our next step then is to order our granules. This one will be pretty quick, but what you can see is it's giving you a constant update on how things are going. And what this has done is this has contacted NSIDC and said, I would like these granules subsetted to this spatial and temporal extent, and I would like you to let me know when those files are ready for me to download. Many of you may have done this through Earthdata Search. If you order your data, you usually get an email or an alert that tells you that your data is ready for download. So this is exactly that same process, but it's happening programmatically. So we can see our order is still processing. The subsetter is actually doing its job to give us smaller files that we can then later download. In cases where you have bigger orders, you might have a set of order IDs. So if you need to see those numbers, you can do that. And great news, our order is complete. It's ready for us to download from NSIDC. So we'll specify where we want to put that data, again in the temp directory, and we will go ahead and download our data. So our data has downloaded, and if we go to this temp directory, we now can find our data. So I know that was a lot very quickly, but the take home is that similar to Earthdata, where you can query and find data in very few lines of code, in Icepix, all of the things that I just showed you can be pared down to these 3 lines of code where you input your search parameters, go ahead and do your authentication, and then go ahead and download the data that you are using. If you would like to use data in the cloud, it's a fairly similar process, but you have to go ahead and create these S3 URLs. And when you're authenticating, you have to do a little bit more to set up your credentials, which here is the code that's required to do that. I'd also like to point out, as I said, all of these other resources. There's other resources for Icepix through the documentation, but we have this series of tutorials, including one on how to download data and use that visualization module that I talked about earlier, and also some guides on ICESat-2 resources in general.